Hi everyone. Today we're going to be working through some methods for calculating the volume of a solid that's generated by revolving or rotating a function around a specific axis. The first type of examples that we're going to be doing consist of the disk or the washer method, which we're primarily going to be using for rotating around a horizontal axis. Okay, so the first example we're going to do is we want to calculate the volume of a solid generated by rotating the region under the curve y equals x squared about the x-axis, and we're going to go from x equals 0 to x equals 2. So the first thing I like to do when I do these examples is to come up with a rough sketch so I can just kind of picture what I'm trying to do. So I'm going to come up with a drawing, and I remind myself I'm going around the x-axis, so I write in a little revolving thing there. And I'm going to go from 0 to 2, so that's all I'm going to put on my x-axis. So my y equals x squared is just our general parabola, and it looks like this. Now I'm going to take this parabola and I'm going to rotate it around my x-axis, which means I'm going to come up with a really light sketch of what it would look like as if I were to do this in mirror image. I'm going to go here. Right, so this is, I'm rotating, it kind of looks like a bell. Right, I'm kind of rotating this curve around here. I'm getting this solid. Okay, so now I've got this circle here. My radius is the distance between the axis that I'm rotating around and the function that I'm rotating around the axis. Okay, so remember the area of a circle is pi r squared. When we multiply that by these tiny little slivers of circles from 0 to 2, I'm going to add up all those tiny little areas of circles, and that's going to give me a volume. Let's write volume from 0 to 2. That comes from here, our definition for what we were given, pi r squared, and we're going to go dx in this case. So now I'm going to go from 0 to 2. Pi, my r squared actually comes from my function itself, because my r here is from this axis to my function. Now I move over a tiny little sliver, it's still from this function to here, this function here, this function to here. So I'm going to go, this is x squared. Don't forget you're going to square whatever that function is. So I'm going to go from 0 to 2, pi, x squared squared is x to the 4th dx. And when I go to integrate that, I'm going to get pi times x to the 5th all over 5, and I'm going to evaluate that from 0 to 2. Using our fundamental theorem of calculus, I'm going to go pi times 2 to the 5th, this is pi over 5, 2 to the 5th minus 0 to the 5th. So this becomes 32 pi all over 5. And that gives us our volume, okay, for when we're rotating this x squared around the x-axis. Okay, so let's do another example.